Have you ever wondered how AI actually works? You hear all this talk about machines learning, but what does that even mean? Well, today, we're going to pull back the curtain on one of the most amazing feats of AI, teaching a machine how to see. And you'll be surprised to find out that this incredibly complex idea is built on something, well, something surprisingly simple. Let's dive in.
So, let's ask the big question right up front. How does a machine, a chunk of code on a computer, go from seeing a bunch of pixels to actually recognizing a face or a car or a cat in your vacation photos? How does it learn to see the world?
To really wrap our heads around this, let's start with a really clear example. Let's look at a machine while it's actually in the middle of learning.
So what you're looking at here is a basic form of AI. It's called a perceptron, and it's being trained. It's being shown thousands and thousands of faces, one after another. And with every single face, it makes a tiny little adjustment, fine-tuning itself, slowly but surely learning the patterns. Eventually, after seeing enough examples, it can look at a brand new face it's never encountered before and make a really accurate guess.
Okay, but how is it learning? I mean, what's the strategy? Well, it turns out machines have a few different ways they can go about this. Let's break down the three main approaches.
Right, so machine learning isn't just one thing. First, you've got supervised learning. This is the most common one. It's like you're a teacher with flashcards. You show the machine a picture of a cat and say, "Cat." You give it labeled data. Then there's unsupervised learning. Here, you just dump a massive pile of photos on the machine and say, "Figure it out." It has to find the patterns all on its own. And finally, you have reinforcement learning. Think of this like training a puppy. The machine tries things, and it gets a reward for doing the right thing and a penalty for doing the wrong thing. It learns through trial and error.
So no matter which of those methods we use, what's actually powering it all? What's the engine under the hood? Well, it's something inspired directly by us. It's the artificial neural network.
You can literally think of this as a digital brain. It's made up of layers upon layers of connected nodes, or neurons. And just like the neurons in our own brains, they pass signals to each other. As the machine learns, the connections between these little digital neurons can get stronger or weaker.
Now I know artificial neural networks still sound super complicated, but here is the secret, the absolute key to understanding all of this. The fundamental building block of this entire system is incredibly simple. Let's zoom all the way in and just look at one single artificial neuron.
At its heart, this artificial neuron, this perceptron, is nothing more than a tiny calculator. Seriously, it just does one thing. It takes in some numbers, does one simple calculation, and then passes a single number out as the result. That is its entire job. All right, let's just watch one do its thing. First up, the neuron gets some inputs. These are just numbers. Imagine there's signals coming from other neurons in the network. So in this case, we've got a pretty strong signal coming in at 0.9 and a weaker one at 0.5.
But here's where it gets interesting. The neuron doesn't treat every input the same. Each one gets multiplied by a weight. Now, this weight is just another number that basically says how important that input is. A higher weight means that input has more say in the final decision. And this is the secret sauce. The entire learning process is just the network constantly adjusting these little weights over and over again, based on whether it got the last answer right or wrong.
So what's the next super complex step in the process? It just adds them up. That's it. Multiply, then add. That's the entire function of one neuron. And there we go. That's our output. This number then becomes an input for the next layer of neurons. See how this works? The first layer of neurons might learn to spot simple things like edges. The next layer takes those edges and learns to see shapes. The next layer takes those shapes and learns to see features, like an eye or a nose. And it keeps going until the final layer can look at all that information and say, "Hey, that's a face."
Okay, so that's the theory. You get a network of millions of these tiny little calculators all working together. But how well does it actually work in the real world? How good is it when you give it a really tough problem?
So yeah, the big question is, how accurate can this system of tiny calculators really be? I mean, what happens when you let it loose on a task like trying to identify any object in any random real-world picture?
Well, just a handful of years ago, the very best systems had something called a top 5 error rate of 5.1%. Now, what that means is that if you showed it a picture, the correct answer was in its top 5 guesses about 95% of the time, which is already pretty incredible, right? But just look at the progress. In only a few years, because of bigger networks and way more data, that error rate has dropped all the way down to 3.57%.
Now, to give you some context, the average human trying to do the same task has an error rate of about 5%. That's right, we have built machines that can, in some cases, see better than we can.
So if you remember one thing today, let it be this. What we call artificial intelligence, it isn't magic. It's just the mind-blowing result of taking a series of incredibly simple calculations and repeating them millions and millions of times. It's profound complexity, born from staggering simplicity.
And that leaves us with one final, fascinating thought. We started by teaching machines how to see, and now that they've pretty much mastered it, what's the next frontier? What will we teach them to learn next?